In this class, we will be experiencing scope and storage classes using process diagram. In our previous classes, we have already discussed the concepts of scope and storage classes, but in this class, we will be practically experiencing how those theoretical concepts will get implemented on the computer. So those concepts we are going to understand by using this process diagram. So before going deep into this class, first we need to understand a data structure called stack. First we will understand that, and after that we will be understanding process diagram. So let's get started with our discussion. So here I have taken the example for this stack, example for the data structure called stack. So this is what we call it as, just visualize this as stack of books. Means a book is placed on top of another one. So there are 5 books. First, at the bottom we are having C programming book, and on the top of it we are having operating system book. On the top of it, database management system book. On the top of it, C++, and above all we are having Python book. And we call it as stack of books. If you take any data structure, every data structure will be having set of rules, and every data structure has to follow those set of rules strictly. So for this stack, what are the rules that we will try to understand, and every data structure will be having some operations. Now, for example, if I want to add a book on this stack, how can I add that? So adding a book onto the data structure is what we call it as an operation, and how that addition, how the book will get added onto the stack are the rules to be followed by the data structure. Now, how can I add a book onto this stack is, if I want to add a book onto this stack, I have to add it only on the top. I should not lift the 2 books on the top, and I cannot place it in between the books. Always add a book or always add an element onto the stack only on the top. If I want to remove a book, I cannot just remove the book in the middle. I have to remove only the book which is on the top. For example, if I want to add a book on this data structure, stack data structure, how can I add it is, I can add only on the top, and let's assume that the book is Java book. So we have to place it only on the top. If I want to remove a book from this stack, how can I remove that? Can I remove C++? No, you cannot remove that. So the rule always says that if you want to remove an element from the stack, always remove it from the top. So only you can remove Java. So these are the rules of data structure, stack data structure. So just try to remember this. Simple, right? Okay. So now we will try to, with this knowledge, we will try to understand the process diagram. So this is the process diagram. The simplest way to understand a process is program in execution. For example, if you take this program, how the programs will get executed, will get converted is, so this program will be converted into zeros and ones. On the top of that zeros and ones, so that complete program zeros and ones, we will be placed with some data structures. Data structures are nothing but implementation. So memory, it is nothing but memory. So this is the process diagram. This is the process for your program. Program and execution is what we call it as a process, right? So let's assume that, so let's understand this process diagram in detail. So here we are having, so whatever the program that you are having, so that program will get converted into zeros and ones. So at the bottom of this process diagram, you are having that program. So the zeros and ones which got converted, your program converted into zeros and ones, that part will be placed at the bottom. On the top of it, we are having a memory space called data segment. What is this data segment is? So this is the place where all the global variables and static variables that are there in your program. So if your program is having some static variables or global variables, those variables will get placed within this data segment. Try to understand this. So these memory, different data structures of memory. So the memory will be placed as a data structures. So On the top of the program, you will be having data segment. Above the data segment, you will be having heap data structure. This is another kind of data structure. We are not going to go deep into this heap data structure. So this heap data structure is used for DMA. DMA means dynamic memory allocation. That's it. No more, nothing deep about this concept. We will be having heap in our process, heap data structure in our process, and that heap is used for dynamic memory allocation. Nothing more about it. On the top of it, we will be having stack. This is very important to understand. We are going to have some discussion on this. So stack, as we have discussed, the same data structure will get implemented. So these are the memory spaces. So what is this stack and what will get stored on this stack? As we have discussed, everything will be placed on the top of the stack. We can remove only from the top of the stack. So these are the rules. Now this stack that is getting implemented, so that we are visualizing here in the process, is just a reverse of it. Okay, the stack means the top is at the bottom and the bottom is on the top. Okay, that is how we are going to visualize the stack in the process. That is how the things will get visualized in the process. Now, what are these stack elements or? What are these stack elements or? This is the important point that you need to understand. This point is very important to understand. What does these stack elements consist of is, whenever a function call is made in your program, a new stack record will get created for that function call. Now what it consists of is, so that stack record consists of all the local variables that are defined within that function call. Once again, I'll explain this once again. So what this stack elements consists of is, whenever a function call is made in your program, so if that function call is having local variables defined within that function, so those variables will be declared within this stack record. Okay, for every function call, a new stack record will get created, and that stack record is what technically called as activation record. Just remember it. Now, every activation record will be having instruction pointer. So we will see the use of this instruction pointer in our next class. Okay, so every stack record is called as activation record. Now within this stack record, along with the variables, we are having a space called instruction pointer. Just remember this. Okay, so now let's understand this process. So how the programs will get executed by using this process, that we will try to understand by using this example. So before going into this example, so this video is part of entire C programming course, and the complete C programming course is available for free, and in our channel you will be getting all the courses related to the computer science and engineering for free. All our courses are full and free. So the link for the playlist or the courses is provided in the description. Click on the link and get the access to all the courses. And please subscribe to our channel. Your subscription helps us a lot to create more content like this. So let's get started with our example. So the example that I have taken here is the example that we have discussed in our previous class. So very simple example. So I'm not going to explain this example again. So as we have discussed, so this program has to be executed. So how this program will get executed? By using this process diagram that we are going to understand. So the rule is, what we have discussed is, whenever, so the first point is, always we are going to search for the main function. So the program execution always starts from the main. So means we are going to call this function, right? So whenever a function call is made, the rule is a new stack record will get created. So, and within this stack record, what it consists of? This stack record consists of variables local to this function. Do we have any variables within this main function? No, we are not having any variables. So, but the stack record will get created, and this stack record is for main. Okay. Now, in the execution of this process, what is this first line states is counter function call. Now, again a function call is made. So, try to understand this. Again a function call is made. So, whenever a function call is made, so a new stack record has to be created. So, try to understand this. This is for counter function call and for this line of code. Try to understand this. Okay. Now, what does the counter function call? Local variables for this counter function call. Are there any static variables? Yes, there are static variables. So, where the static variables will get created? The static variables will get created in the data segment. Okay. So, now we will take that as static underscore count. The variable name is static underscore count and it has been declared as 0. Okay. So, now what are the local variables? It is, I'll take it as a underscore c, means auto underscore count, and it is a local variable and the value of that variable is 0. See here, local variables will be created within the function call and the static variables are once for all, they will get created in the data segment. So, this is going to get you that understanding of storage classes. So, storage class static is going to give you local scope but global lifetime. Okay. Now, we will understand that also. So, now these two has been declared and after that auto count will get incremented. So, auto count got incremented and the value is 1. Okay, and after that static count gets incremented. Now this value is 1. So the static count is in the data segment, so it got incremented and it has been made as 1. Now the printf will get printed. So auto is going to get the value from here, which is having a value of 1, and static is having a value of 1, so that will also get printed. Done. Now, all the lines of this counter is done. Now, the complete execution of this counter has been completed. So, now what happens? Once the execution of the function call is done, that function call will be removed. We are going to remove from the stack. So, as the stack is tilted upward down, so here the stack is upward down. Okay. So, now as it is upward down, so which one will get removed? So the topmost element is this and the bottommost element is this. So the topmost element will get removed as the execution of this function has been completed. So this stack record will be removed from the stack. Okay, got it? So we are in the first line of execution. So this is our second line of execution and this is our third line of execution. Now we will understand the use of instruction pointer. So whenever a function call is made, within the main function, we have made a function call. So now what happens is, at which line the function call is made will be stored in the instruction record. So in the first line of code, we are abruptly moving from this main function into the another function call, right? So that needs to be remembered. So who is going to remember that line of code? In which line that function call has been made is remembered by instruction pointer within the activation record. So that is the use of instruction pointer. So try to understand this. Okay. So now in the line number 1, a function call has been made and the function, all the functionality related to that function call has been done. Now this has been removed from the stack. Now we are going back into the function call. So where the function call is made? Here in the main. Now at which line we stopped our execution? So this is existing on the stack. Means, so in the line number 1, we have executed the counter function. Now the next line has to be executed. So in order to remember that where to start our execution, we are maintaining a record called instruction pointer. Within that instruction pointer, the line number of the function call will be stored. So this is how the programs will get executed. Okay. So now we are done with this, and the next line will get executed. We are going to go with from the next line. What is the next line? Which is 2. The second line will get executed. The second line is again a function call. Now when it is again a function call, now let's see this. So this has been removed. So as we have seen that this has been removed from the stack, it is no more existing. So what we have to do? So this is the state of the stack after completion of this one. Okay. So now we are in the second line of code. Now this second line of code is also a function call. Now whenever a function call is made, what is the rule? The function call, whenever a function call is made, a new activation record will get created, and this function call is for which function? Counter function. And what are the local variables for this? See this function call. What are the local variables? It is auto count. So try to understand this point. This is where you're going to auto count is equal to 0. So this is a fresh function call. What are the values that are defined here? Here it is defined as auto count is equal to 0. But do we have access? So can we reassign this static count as 0? No. This is global lifetime. This is going to be there, and we cannot change this value for every function call. Even though it is local to this, the access is local, means whenever this function gets executed, then only we can access this particular static variable, but it is going to stay until the complete execution of this program. Okay. So now what is this value? It is 1. Now auto count will again gets incremented, which will become from 0 to 1, and the static count will again get incremented. So now the value of 1 will become 2. So that is what the scopes and the accessibility and the lifetime of the variable is decided. Try to understand this part. Okay. Now if you print, what is the auto count value? It is going to print, the auto count is going to print 1, and the static count is going to print 2, because it is in the data segment. Similarly, the global variables. Try to understand this. Now we are done with this function call. So whenever the function call is done, this particular, all the variables within this function call will be removed. The lifetime is completed. So now we are done, and whenever a function call is made, that instruction pointer has to be updated. Now here again a function call is made in the line number 2, so we have to store that line number. Now after this, after we again go back to this main function, this is still existing in the stack. This is still existing in the process. So this is having life, right? Now we are in the second line of code. In the second line of code, main function, a function call is made. We are going to go into the next line of code. In the next line of code, again the third, again a function call is made. So again an activation record will get created. So this is how the programs will get executed. So this is one of the very beautiful concept by which you are going to get the clarity on most of the concepts. Okay. So now again, whenever a function call is made, all the local variables will get created. So here I made it as 0. So the local variable, so this is the local variable which is having a, this is already defined. So this is a fresh copy. Okay. So the previous one was deleted, right? But the static variables are stored elsewhere. So it is already having a value of 2. It remains the same. Okay. So now again the counter, this one will get executed and it will get incremented, and the static will get incremented, which is going to be 3. And here is the values will get printed. So if you print this A, it is going to be 1, and if you print this static count, it is going to be 3. Okay. So this one is completed, means this one will get removed, and this instruction pointer needs to be updated whenever the function call is made. So in the previous line of code, it is 3, and the fourth line will get executed. Because we don't have any fourth line, the execution of the main is done. So now the main will also get deleted. Now once the main got deleted, there is nothing to get executed for this program. So the entire program will be removed from the RAM. So your entire process will be removed from the RAM. Okay, so this is how the programs will get executed. So this is how the process diagram is going to help us. So to understand the concepts of most of the concepts. Okay, so in the next class, so that's it for this class. In the next class, we will be using the same process diagram, but we will try to understand recursion. Okay, so that's it for this class. See you in the next class.